Backyard Green Films is proud to present this episode of Agri-Culture with your host, Alara Bowman. Alara and her husband Rick travel throughout the land in their teardrop trailer that they have nicknamed Maggie, bringing you stories about their travels and the people they meet. They visit farmers, ranchers, and just about anyone who loves putting their hands in the dirt or their feet in stirrups. For the past 3 years, they have been filming a documentary about heritage breed animals entitled The Holstein Dilemma, Heritage Breeds, and the Need for Biodiversity. In those travels, they have gotten to meet some very interesting people. Here's one of those interviews.
Hi, this is Alara, and welcome back to our podcast. If you ask most people to list the top 5 things that humans cannot exist without, one of the things that'll be on everyone's list is food. Though it varies from person to person and there have been some outliers, most people will be able to last, at max, for 30 days or so without food before expiring from lack of nutrition. People will get really desperate way before you hit that end point, so running out of food is not ever a good thing. It's kind of a no-brainer that if you control the food supply, you control those affected by it. And you control it in a really primal, non-negotiable way. So it makes sense when you think about it that food security is a real concern for a lot of people, and not just for individuals. Many countries realize the importance of food for their people's security and happiness, but also from a strategic standpoint. That's why there are organizations across the globe that are dedicated to ensuring that the food supply stays predictable and safe. Whether they be global or local, governmental or corporate, nonprofit or otherwise, they all pretty much realize that everyone has skin in the food game. Ugh, okay, that really sounded bad. But it's probably pretty apt because our skins and everything else are completely dependent upon the availability of food. The United States government is no different from the rest of the world in this regard. We have a whole executive department called the U.S. Department of Agriculture, the USDA, dedicated to that. I'll quote from Wikipedia here. It aims to meet the needs of farmers and ranchers, promotes agricultural trade and production, works to assure food safety, protects natural resources, fosters rural communities, and works to end hunger in the United States and internationally. Wow. Okay, so now you're listening to this on a podcast, so you might not have time to really soak in the number of directions that previous paragraph might encompass. The support goal is pretty plain. If you've been listening to this podcast or watching any agricultural news on the planet, you probably also understand why the genetic security part is important. But think about how they do it. Acquiring, evaluating, preserving, and distribution. And what they do with it. Plant, animal, insect, and microbial material. To me, that means field scientists, collection, travel, laboratories, vats, documentation, transport security, more labs, more collection, freezers, studying, more labs. Okay, so you get the picture. For all the important agricultural plants, animals, insects, and microbes that we might find important. All of them. The USDA is a big department of a big country in a big world. So just a conceptual historic note here. Because we're so dependent on food, it's one of the things that's been used strategically throughout history, either as tools or weapons in war. In a way, the security of our food system could be classified as a Department of Defense issue as much as a USDA issue. It's just that important. Go look up the phrase victory garden if you don't believe me. As we record this podcast, it's the anniversary of the siege of Leningrad. If you remember the seed bank scientist story, you know what a horrible and worthy duty it could be to be responsible for preserving the entire food supply of a nation, especially when it also represents thousands of years of agricultural history. There's no pressure there or anything. The man we're bringing to you today on our podcast will hopefully never have to face that same choice as the food bank scientists of Leningrad, but he does occupy a somewhat similar position. His name is Harvey Blackburn, Ph.D., and he works at the National Laboratory for Genetic Resources Preservation, otherwise known as the NLGRP, in Ft.Collins, Colorado. I'll read you the excerpt from his bio on the USDA's website, but the link is in our intro if you'd like to follow it further. Harvey Blackburn is an animal geneticist and the coordinator of the National Animal Germplasm Program, NAGP. He manages the development and acquisition of animal germplasm at the NLGRP, and he coordinates the 6 animal species committees that advise the NAGP about collection development. In other words, he's our guy. Not just our guy here for the Holstein Dilemma documentary, or the heritage breeds projects that Backyard Green Films is involved with, but also for the planet in general. When Matthew McConaughey goes up in the ship in the movie Interstellar with a big bank of germplasm to reboot the population, they probably cut the scene where he goes to Ft.Collins and the NLGRP. He walks into the office of Dr. Harvey Blackburn and says, "Sir, it's time. We need the cryobank to save agriculture as we know it." Okay, well, a little bit of that was for dramatic effect. But my point is, Dr. Blackburn is that guy. And he was gracious and patient enough to take time out from saving the universe to give us an interview and a tour of the NLGRP. Just for visuals, you might imagine us in a big cooler room with the cryo vats in long rows around us. You can hear the machinery and the fans in the background. And it has the industrial kitchen feel to the room with tongs and gloves and easily disinfected surfaces everywhere. We know there is a bit of background noise that you might hear, but we didn't ask him to turn off the fans, because they might be, important or something. In the U.S., our population is about 330 million people. I can't even imagine how you might sleep at night, fretting over the long-term stability of perishables, non-perishables, and future perishables. Toss in a few old diseases, constantly adaptive new diseases, and genetics issues in the mix for good measure. Dr. Blackburn is my hero. The Penn State docs even named a cow after him. It is, no doubt, not enough. If you would first please state your name and your title.
Sure. I'm Harvey Blackburn. I'm the National Coordinator for the National Animal Germplasm Program, which is part of the Agricultural Research Service within the U.S. Department of Agriculture.
Wow, if you could explain to people, the average layperson, what the germplasm program is.
Sure. Actually, we're standing today in the vault where we store animal germplasm. Our mission here is to acquire a broad range of genetic variability from our livestock populations in the United States to use for a number of purposes. We can use this germplasm to reconstitute entire breeds or species if that is required as a result of a catastrophic event. And perhaps in the shorter term, we also use this material for various research activities. Researchers come to us, they use samples for genomic studies to try and better understand livestock populations in the United States today. We can also distribute samples to people raising heritage breeds at any point in time. And we've done that to a large degree with a number of different breeds within the United States, where these populations, because they are small, they have a relatively narrow genetic base, have come to us wanting to use some of the samples that we have here in the repository to reconstitute or to add genetic variability of the within their population. So by doing that, while we help broaden the gene base, often there's selection pressures or items that breeders are selecting for are missing from a population. And they can come here to the repository to try and use animals that we've cryopreserved for that purpose, to introduce this genetic variability that they're wanting.
So now my next question would be, is this more, this is a government operation, is this more like the public library or Amazon.com, where you have to purchase or you get to borrow? And
Sure. The U.S. Congress actually, through legislation, established this program. And part of their legislation placed a specific requirement on USDA that any germplasm that we have stored in this facility that is part of our public collection is distributed freely to the public. There's no cost for these resources. However, we do have some criteria because we want to make sure that, one, we don't deplete our storage of germplasm here in the repository totally for a particular animal or a particular breed. And so we want to maintain a particular base that we can always have in case we need it. And the other issue is that we address is whether or not these samples might be derived already from the public sector, because we do not want to interfere with the exchange of genetic resources among the private sector, the various breeders that are out there doing this for a living. So this is something we take very seriously here when people make a request on us, that we are not interfering with anybody's business practices.
How do you have a waiting list or something that allows people to choose which we...
Well, it's not a waiting list per se. Actually, what we have developed as part of this program is a public website where the public can come in and they can actually view the samples that we have here in the repository, and based upon their review, if they're interested in using material, why they can actually submit a request online. And that's how we send samples out, is everything starts with the initial request, and then we're also able, as we're doing that, to subtract those samples we may be sending out so that we always keep a very accurate count of the material we have here in the repository.
So I went online to look at that database, and I noticed that it's not just livestock. You have all kinds of bees, you have aquaculture.
Yes. In addition to what we normally consider as livestock, we also address aquatic species. For example, we have catfish, we have trout, we have salmon, we have oysters actually here in the repository as well. And of course, these all tie into agriculture. They're part of agriculture. They're not normally kind of in the same mode of operation, say, that some of our livestock sector is. And it's a little bit different scenario for them because we often are dealing with populations that, while they may be raised, may not be really considered fully domesticated like we normally think of our livestock species. Our work with honeybees has just started, and essentially there are a number of issues that honeybee producers are facing. Honeybees, of course, are important from the standpoint of not only honey production, but really when you get out into California in particular, how those honeybees are used to pollinate species of plants like the almond groves. They're an extremely important component to that part of agricultural production.
Yeah, we're from California, and it's 80% of the world's almonds are produced in California, and it's a huge part of our economy. So there's an economic impact to a lot of these things that you do, correct?
Absolutely, there's an important economic impact that we can have with what we have here, not only in terms of the issues that I've already discussed about kind of catastrophic events happening or introducing genetic variability that we've talked about, but we've also had industry come and use samples from the repository to genotype, looking for lethal genes that may be present in a population. And in one instance, why we've let a particular association have a sample from the repository on a bull that there was no other material on, and they were able to genotype that bull, and using that information, why it saved that particular association and the associated breeders over $500,000. So a very small example of the economic impact that we can have on livestock industry.
One of the examples that comes to mind in economic terms is also the salmon, the aquatic animals. It's a huge portion of the economy of some states, the aquatic animals that we have. And I think some people often think, why is the United States putting efforts to conserve the salmon runs or the fish ladders? But there is a huge economic impact in some states by honeybees or fish or something of that nature, is there not?
Well, yes. I mean, there are huge economic impacts in the livestock sector in general. If we look at whether you were talking about dairy or beef production or swine production in the Midwest, clearly issues with, like you were mentioning, with salmon, where we have a situation where you have these wild runs, not only from the standpoint of the species itself and the viability of the species, but if we also consider the importance of those salmon populations to Native American populations in the United States, it becomes really not only of economic importance, but also culturally important for certain groups of people in the United States.
It must be a difficult thing to balance in terms of the priority system. How do you choose what is the most critical priority to start collection first?
Well, this was an issue that we crossed very early in the program because we had nothing started. And so if we go back to 1999 when this program first started, why one of the first issues that we were confronted with is how do we determine what populations we conserve, what we don't conserve. And what we did at that point in time is we brought in groups of people that were interested in conserving livestock genetic resources. So this included people from industry with both commercially viable or big breeds, as well as rare breeds were represented at that table. We had university people there. We had other people from USDA participate in that. And essentially, the consensus around the table was that we needed to focus on all of our populations, that we just couldn't take rare breeds or heritage breeds or commercially viable breeds as a way to advance this program. We needed to have a focus across the spectrum. And that has been kind of a unique approach in terms of other national programs as we look at programs outside of the United States, where they've often focused just on the rarest of breeds. And they've not really focused on commercially important populations in their country. And from our perspective, I think by broadening this out, it's made the program a lot more robust than if we would have stayed more narrowly focused. It does create some issues as to how do you go about acquiring this germplasm and bringing it into the repository. One of the nice things about this issue is that as we look and we talk to various people within the livestock sector, there's probably a very unanimous kind of consensus that this is an important program and people want to become a part of it. And so we have people from all various aspects contributing to our repository, and we try and leverage a lot of those activities, as much of those activities as we can, to help us acquire this material.
One of the things that I found interesting in our process of this documentary is that people have a tendency to view industrial agriculture and small farm agriculture or heritage breed agriculture as two separate things. But to me, I'm a systems theory fan, and it seems that they are highly interconnected in some ways, and that the genetic resources of breeds that may be isolated breeds with certain genetic properties might be very valuable in industrial agriculture. One of the examples might be the Blackburn disease that hit the turkeys in just the last couple of years, the poultry diseases. I understand that there was one with the chickens in the 50s or 60s. There was one of the diseases that nearly wiped out the poultry, the entirety of the poultry industry, and the introduction of a different line of genetics might be important. Have you found that industrial agriculture finds some of these different genetic lines important as well?
Well, I think as we start looking at those sectors of livestock agriculture. Industry is always looking for ways in which they can improve their productivity. And often they feel they can do that within the population that they have. There are other situations, though, where they clearly recognize the need to bring in other genetic resources to use as they may want to try and achieve a particular goal they have in mind. So that becomes really kind of their issue, I think, to address. And it's also important to keep in mind that while, yes, this is all animal agriculture, many things cross over between highly industrialized and maybe the heritage breed type activities, but I think it's a big tent that enables a lot of actors to come in and pursue the activities as they deem appropriate.
Have you found it that with the intellectual property issues, again, you spoke earlier of the genetics, the ownership of the genetic lines, some people that you don't want to step over those lines. Have you found it difficult to collect some of the genetic from people who feel possessive about those genetic lines?
There's always people that feel their genetic resources are highly proprietary. They don't wish to share those, and that's their decision. We have taken the approach that much of the material that we have here in the repository has been donated to us by the sector at large, and so it is part of a public collection. And so while we welcome the interaction with some of these other groups that may or may not want to share their resources or have their resources here in a repository like this, why we're always here to try and work with them the best we can.
If you could go over again, please, the different biology that you have in this building. Would you go over that again, please?
Sure. This repository was built by USDA to cover a broad range of different life forms. So in this repository, not only do we have animal genetic resources, which of course includes birds, mammals, fish, but it also includes insects like the honeybee, like screwworm. We also have the world's largest collection of plant genetic material located here in the repository as well. And that plant effort really kicked off this whole program because originally this building, this facility and its mission was started with plants back in about 1957. So we have a long history of doing this within USDA and doing it here at this location. In addition to the various life forms I've mentioned, we also have a program that we're just initiating with the collection and storage of various microorganisms here in the facility.
So in terms of the storage, you also said that you do research. Would you go over that a little bit, please?
Whenever you start trying to develop genetic resource collections, there's probably three primary areas that you need to emphasize, and those are to understand the genetic variability of the populations that you're trying to collect. There's an issue of how you're going to store this material once you do collect it, and then the information systems that are needed to support knowing what has been collected, what's missing from the collection, and to have an understanding of not only the phenotype of the animals, the number of samples in the collection, but then also we've started initiating work in terms of how do you store genomic information as well. So to underpin those three elements, why we need to have research activities that are focused on trying to address our needs. For example, with genetic diversity, we do a number of studies, or we've done a number of studies over time, looking at the genetic variability of livestock populations and how different they are from one another, using molecular marker techniques. We've also looked at various mechanisms in terms of cryopreservation, the process of storing the germplasm cells, whether it's semen or embryos, or in some cases we have ovarian tissues from chickens stored in this. So, but to do that, we have to be sure that not only can we collect them, we can freeze them, can we revive those cells and have them survive those extreme processes to where they can be then used to reconstitute animal populations. So we have research activities in those various areas in terms of trying to address those issues.
Now you use that term reconstitute and makes it sound like powdered milk in a way. So if you have a population that you can reconstitute at will, one of my questions would be, conceptually, do you think that if you reconstituted one of these animals now, or if you reconstituted the animal in 200 years, the animal would respond the same way to its environment, climate, all of the above?
Yes. In other words, because we've tried to sample very broadly the livestock populations that we have in the repository, if we were to try and reconstitute, the whole concept is that we would be able to bring back that population as it functioned at the time that it was sampled. Now, what we've also discovered is that many of our samples are at the extremes, either higher or lower than the breed average. Okay, and what this means is that if we have an animal that's, say, extreme in terms of its higher in productivity for, say, milk production, and the breed average is down here, why, it's going to take the breed average a number of years or generations to catch up to this one animal. So this animal could still be very productive 20 or 30 years after it's been collected. And so that has some very interesting implications in terms of how we build a collection, how we reconstitute populations. We may want to have something from the 1980s versus having something from the 1990s because the populations would change. So we can go in and we can look at how these animals perform at these particular points in time when they were collected and make those kind of decisions.
So if there's adaptation necessary for breeds, especially in this changing climate, it is changing fairly quickly, do you think that we can bring some of these breeds back in 100 years and they still will be able to function with the bacterium and all those things that are necessary, do you think?
Well, I can't put myself in that situation of 100 years, but you know, what we want to do is to be sure that we have enough genetic variability to have the best option of achieving those type of goals. Do we know that the animal will respond perfectly in a particular environment 200 years from now? No, we don't. But that's an issue that we can address if we need to, because we can always pull samples out, reconstitute some animals, see how they perform. If they fall short, we know we don't want to go in that direction. We look somewhere else within the collection. As you start thinking about these collections and what we are learning about the genetic makeup of these populations and our ability to understand the genome of these populations, it will be at a point where we'll be able to look at the sequence information on these animals and make a determination prior to actually pulling them out, whether it's going to be worth our efforts to do so.
So I have to ask you, when you were young, what made you get into this field, or did you just sort of fall into it?
Well, I come from a livestock background, and specifically a purebred livestock background. So in some ways, breeding and genetics, that was my specialty going through school. So that was really a basis anyway for coming into this type of work. Because one of the big questions we always face is, okay, how do we use or better use breeds that we have? How do we better use genetic resources that we have? So that was really my background in coming into this kind of program.
Many of the farmers we've spoken with grow mixed breed animals, but they take a purebred this and a purebred that, and they mix them together to get the characteristics they need.
Yes.
So in many ways, you can do that same thing here as well.
We can do that same thing here, and if you think about it, humans have been doing that for thousands of years. I mean, we can go back to archaeological works, and we can see that as far back as Roman times, there was selection going on at that time, determining what animals they wanted to regenerate or breed, what did they want to breed for. All these things have been done for a considerable period of time. We've just changed the way in which we do it.
Do you feel that there's less diversity now, or more so with the advent of globalism and the ability to travel?
Well, that's a very interesting question, because it depends on the scale that we're looking at that problem. Obviously, when we look within particular specific breeds, there are issues of diversity. However, if we take all of our breeds together, in the United States in particular, we've accumulated a vast amount of diversity in this country. I mean, if we just take sheep, for example, we have sheep from Central Asia, we have sheep from the Middle East, from West Africa, from Southern Africa, from Europe, Northern Europe, from the UK, from Australia. So our breeders have really been very active in terms of bringing in genetic material for us to have here in this country, that we are really we have a very diverse collection of genetic resources here that probably you don't see in a lot of countries around the world, because they don't have the range of environments that we're trying to produce livestock in, and their interests just aren't as diverse and as broad as what our interests are.
Now, I noticed that on the website, under the selection criteria, where you can choose which animal you might want to request a sample from, that there are collection spikes in certain years. Is that because funding got better, or because there were more requests, or?
Well, yeah, a lot of that depends on, in terms of the collection growth, what our funding is looking like at a particular time, other activities that we may have ongoing within a particular situation. Sometimes we've had substantial donations from the private sector. We had one company that had been in the business of selling bull semen since the 1960s, and they had kept samples on every bull that they had ever collected and sold. And at one point in time, they decided that this was too expensive for them to maintain, and they donated the whole collection to us. Well, that was about 7,000 animals, about 200,000 units of semen that was in that donation. So we have a lot of these kind of situations that come in at various points in time as well.
There are a lot of scientists in this building. Was that one of those celebratory moments, or are there more exciting moments than that? Because I would think that would be right up there.
Well, yeah, certainly that was an important point for us, to have that kind of donation, because in essence what it's saying is that as an industry, or as an industry representative, we're supporting what you're doing, we believe in what you're doing, and so they were willing to participate that way. And so that was a very important effect for us. But we have a number of other kind of activities that have occurred which we would consider equally exciting. For example, our ability to harvest ovaries and testes from chicks that are 1 to 3 days old actually changed the way that we manage or go about trying to build our poultry collection. And in addition to that, by having that technology, all of a sudden a major broiler breeder in this country decided, yeah, we're willing, we're ready now to store or back up some of our populations with you. And so Sometimes we get these technological advances that help. Industry becomes interested. Things in industry change, the dynamics between various companies. Company A buys out Company B, and maybe Company B wasn't really engaged with us, but Company A is. And so all of a sudden they say, well, now we have these populations, we're going to back them up with you. So we have these kind of situations occur across the time which we've been working on this program.
So would you make this akin to a hard drive backup or a cloud backup?
That could be an analogy, certainly, that it's a backup for the sector as a whole.
Okay. Just on a physical process standpoint, it's an extremely interesting process. We watched them harvest eggs from the salmon when we were up in Portland. How does one go through the process? Is it just a collection, is it just a process of milking the organ, or is it you have to break it down, put it in a test tube, separate it? Does it depend on species?
During the collection process, of course, that varies vastly as you go across life forms. How we collect milk from fish is much different than how we collect semen from boats. And so you always have to start with the species type that you're working with and those process and actually getting the collection. Okay, once it's collected though, why, as you've seen, we don't have really animal holding facilities here. And so that material either has to be frozen in the field or it has to be shipped to us where we freeze it here. And we have protocols to do all of that. So in many instances, we've gone to the field, we've collected, we've frozen in the field, brought back frozen samples, or we've had people send us samples like I've mentioned, and we can freeze them here and there.
So if you had to tell the layperson why you think what you do is important, what would you say?
Sure. The important aspect of what we are doing here in this facility, conserving genetic resources, is when you look at the issues of food security. In this country, we like to have food affordable for people. Genetics underpins all those aspects. And by having this genetic diversity here, we're enabling researchers and industry alike to work toward more productive animals, increasing production efficiency, which ultimately serve the consumers of the United States.
We'd like to thank all of the scientists at the facility in Ft.Collins, Colorado, as well as all of the USDA personnel that were kind enough to give us time from their schedules. East Coast, West Coast, or in the middle. They were all some of the hardest working people we've ever met, and the most gracious. Completely ruined my previous perception of government workers, in a good way. If you liked our podcast, please subscribe. This is how we keep going. And please tell your friends to join us. Please feel free to post any questions or comments that you might have to our social media sites. Our Twitter feed is at Backyard Green Films, spelled BKYRDGREENFILMS. Our Instagram is at Backyard Green Films, BACKYARDGREENFILMS. Our Facebook is Backyard Green Films. Our YouTube URL is youtube.com/backyardgreenfilms.
We would like to thank Dr. Blackburn and all of his staff at the USDA's National Animal Germplasm Program in Ft.Collins, Colorado, for taking the time to speak with us today. You have been listening to Agri-Culture with your host, Alara Bowman. Please tune in for more upcoming episodes from our travels. I'm Rick Bowman, your behind-the-scenes editor. Until next time. If you'd like more information about the USDA's Agricultural Research Service Program or any of their other services, please visit their website at usda.gov. This has been a presentation of Backyard Green Films Productions, all rights reserved, copyright 2019.